here's what my UV-Vis setup looks like. There's some samples in front of me and their instrument is off to the next. Next I'm going to show you the spectra. The black one is the GTC and the peak's around 470, you can see that. But the red one, M2000 sample, you cannot see. You cannot make out where the peak is and it's not in the same place. There's lots of interference there. Same is true with all the other samples that I received last year. The black is still just plain GTC and the other ones are just kind of a mess. I'm going to show you what happens when you add to the GTC. Now here's the GTC itself with iron and the acid. So all you're seeing here is this red color that I normally test for. Now here I am adding some of the Roche SPU sample because I have the most of it. So I'm adding that here. And watch what happens to the red color. It just goes away like entirely. So depending entirely on the age of that stuff, how much it's been exposed to acid, what other buffers are in it, it can take away from that color. The great thing is the silver, silver didn't affect it at all. I could add the silver, it still turns white, still precipitates the same amount of time. So there's no interference from the analytical method, but using the analytical method using silver, there's no difference. But using iron to detect it, you can't tell when the reaction is done using iron, and that's pretty instructive for us because how much citric acid there depends on what it was and how long it's been exposed to the atmosphere. And there are other things too that could be interfering, and it plays with that color. So we really can't trust that color. That's the lesson for today. I hope this helps.